Skill 7 is going to be our last of our algebra sections for a while, and then we're going to skip over to some geometry concepts. So I just wanted to clear up some exponent rules. I want to look at function notation, solving inequalities, and finding the slope, x-intercept, and y-intercept of a function. So first off, let's look at these rules for exponents again. So when I'm dealing with the rules of exponents, I want to remember my rules, and my rules are if I'm multiplying, I add. And what does this mean when I have a whole list of these? So let's kind of divide these up. And first of all, let's take care of our numbers. So for multiplying, we get a 12. For numbers, variables, we add our exponents. So 4 plus a negative 3 would be a 1. And y, we'd get a 7. And that's all the further we want to go with problem number 1. Problem number 2, again, we take care of numbers first. So a power to a power, we're going to take 2 to the third power, a to the first to the third power, we multiply powers, b to the 12th. You'll look for multiple choice answers, and remember that 2 cubed is 8. The hardest one sometimes is our division problem. So think of numbers first, so you can't reduce 3/2, so 3/2 would just be in your answer. Power over power, x to the negative 1 minus 2 would be x to the negative 3. And then y 3 minus 4 would be a negative 1 also. So if we have negative powers, remember when we have negative powers, we would look at our multiple choice. Negative powers mean that they're in the bottom, so we should see a x cubed in the bottom and a y to the first in the bottom because of negative powers. At this point, it might just be helpful to remember what a negative power is. If I have 2 to the negative 2, it's 1 over 2 squared, or 1/4. Sometimes when we look at numbers, it looks weird, but 3 to the negative 5th is 1 over 3 to the 5th. And so when you punch out this in your calculator, 3 to the 5th is 3 times 3 times 3 times 3 times 3. So we would get 243 in the denominator. The next thing I want to look at is our function notation again. And when we use our function notation, this is just a fancy way to say what is f of 3. We will find f of 3 by putting in a 3 wherever we see an x. And sometimes we can do this just with our calculator. That's the fastest, quickest, easiest way. You don't get any extra points by going 3 squared times a negative 2 plus 4. I would just punch this out wherever I see an x, put in the value, and look for your answers. The next problem I want to discuss is a continuation on yesterday's problem with solving for absolute value. But notice here we have an inequality. So the first thing to do is to solve for the equals. So we take 5 plus r and make it equal to 1. Remember, that's one of the answers. And when 5, the inside of the absolute value equals a negative value, this is going to be another answer. But this is not an equals. So what we have here is we have a inequality. So we have to determine, do we shade inside these endpoints or outside? And basically there's some rules, but sometimes I forget about rules. So take a look at, if I plug in a -6, I get a 1. If I plug in a -4, I get a 1. So it can't be, because of the less than, it can't be equal to because it doesn't have an underline. And then we have to determine one of two things. Is it outside the endpoints, or should I shade inside the points? And if you're a rules person and you remember that, if it's a less than, we shade inside, and if it's a greater than, we shade outside. But I would suggest to just plug in a point. So inside here would be a -3. So if I stick in a -3, 5 plus a -3 is a 2. And I'm sorry, -5 is a point inside. So 5 plus a -5 is a 0. And 0 is less than 1. So we would shade inside these points. So inequality is similar to yesterday, that we solve first, but then we have to determine which way to shade. And the last problem that I want to discuss today is a problem that you guys have been seeing a few times, and I think you're used to seeing slope, you're used to seeing y-intercept, but what some of you guys aren't used to is seeing the x-intercept. So let's remember what each one of these are. If I'm in a y equals mx plus b, we know that b is the slope. M is the slope, and we know b is the y-intercept. Okay. What we forget sometimes is to find the x-intercept. We set y equal to 0 and solve. So the x-intercept is when y equals 0. Remember, the y-intercept is when x equals 0, and the slope is the coefficient in front of the x. But remember, that only is true when we solve an equation for y. So if we have this equation, we're going to have to do some manipulating around to solve for y. So if I look at this equation, if I leave this on this side and put everything on the other side, I can solve for y. Again, how do I solve for y? I have to get y by itself, which means I have to multiply everything by the reciprocal. So now I get a y equals what? If I multiply through, I get 2/5 x. If I'm multiplying by a 2, that'll cancel. And I have my y-intercept is -13/5. So most of the time when we see this equation, we see the slope. The slope is equal to -2/5. We see the y-intercept is equal to 13/5. But what sometimes we have a difficulty with is finding the x-intercept. So if I wanted to find the x-intercept here, I'd plug in y equal to 0. If I solve for x, that means I'm going to get x all by itself. This time I would multiply both sides by -5/2. So the x-intercept, the 5's would cancel, and the x-intercept would be -13/2, 0.